Hello, everyone. Thank you for joining my talk today. And today I'm going to discuss how lead in house dust and soils may be connected, but most importantly, how paint lead species might be driving bioavailability in house dust samples. And so this is work that is being conducted at the EPA. My project lead for this is Karen Bradham, and I'm a EPA federal postdoc. And so first off, why are we looking at this? Well, we know that lead in house dust is a major issue when it comes to childhood exposure. And so children are much more likely to be impacted by this due to ingestion, and also the negative impacts of lead, especially to the brain, are highly negative when it comes to childhood exposure. So inhibiting the amount of lead actually going into the bloodstream upon ingestion is of great importance, which is why we're looking at bioaccessibility and bioavailability. And American Healthy Homes has been a nationwide study that was originally implemented from 2005-2011. There's now a second part that we're actively working on that was designed to kind of assess how much lead exposure there is, and looking in general at a lot of different contaminants of concern, and relating that potentially to demographic variables. And so my piece of this was, okay, we have this house dust and we have soils for some of these that are connected to them. How do they relate? How does the relative bioavailability, which is a measure in terms of how bioavailable is something compared to something that we assume to be 100% bioavailable, which is a lead standard, lead acetate in this case. And so we're looking at, all right, what are the drivers of relative bioavailability for these house dusts? And can we correlate them to highly researched NIST standards? And then finally, looking at how house dust and residential soils are connected via speciation, which should inform bioavailability. And so we did a variety of different analyses to understand the connection between these samples and drivers of bioavailability. And these include a variety of different analytical approaches, such as ICP-MS analysis after digestion, in vivo digestions as well, looking at the mouse model to kind of gain an understanding of these relative bioavailability measures. And then also looking at Argonne National Lab to gain an understanding of the lead species present in house dust and connected soil samples. In summary, we found that relative bioavailability was quite elevated for the house dust samples and for the soils. We can see here that these are connected based off numbers, so dust 1 and soil 1 are connected. And relative bioavailability was actually over 100%, which is possible. And it showcases that they're extraordinarily high, extraordinarily bioavailable. That should be the main story taken away from those samples. But we see that these are quite high for all dust soil connections. And the dust for other samples, the dust seems to be more available than that found in the soil. This was pretty low relative to what we typically see, which was interesting as well. And so taking this now further, we used X-ray absorption spectroscopy to kind of gain an understanding of SRMs and how these SRMs explain and resolve our samples. And so the long story short here is that whenever we have a paint SRM, in this case, it's typically driven by cerusite and hydrocerusite, which is lead carbonate and lead hydroxycarbonate, respectively. These are very available phases of lead, and they're originally from the white pigment in paint. And so here we can see in summary that all house dust samples had a lead carbonate or hydroxycarbonate phase, and that although dust and soil phases are related, dust had contamination that seemed to be unique to interior sources. So that's something of need for a future investigation. Additionally, it helps to resolve our relative bioavailability, where we see increases and decreases that may be resolved by speciation analysis. And so as take-homes here, lead contamination is important, exclusive and related to soils. And also, we see some phases are lower, which plume of the Yara site seems to be a phase driving bioavailability lower. And there needs to be further work connecting speciation analysis for more recent samples and how these phases may change over time to better understand lead exposure to to children in general. And with that, I thank you for your time and thank you to my collaborators.